Okay, so now let's talk about the next two types of sequences that we get. Now these sequences are talked about in much more depth at grade 12. But I want to give you an introduction into this because certain times you'll be given a question. Well, in fact, oftentimes you'll be given a question and the question may not be in alignment with the geometric and linear sequence. So once you have that to be the case, then you go to quadratic or cubic sequences. So let's look here. With quadratic sequences, the second difference is constant. Right. So remember when we were given a sequence like 2, 4, 6, 8, 10. Right? Then if we check the differences between the two terms, it gives us 2. So then we know since the difference is constant, since we have a constant difference, because it's constant, it's the same, it doesn't change, then we know that this is a linear sequence. Understood? However, what makes a quadratic sequence quadratic is that the second difference is constant. Very important stuff. So let's look at this here. Let's say we're given 1, 4, 9, 16, and 25. The standard quadratic sequence will be Tn is equal to n squared. So if I put in 1, it'll be 1. If I put in 2, it'll be 4. If I put in 3, it'll be 9. At the fourth position, it'll be 16. At the fifth position, it'll be 25. What happens is if you find the difference between the two terms, we get 3, 5, 7, 9. And then if we find the difference again, we get 2, 2, 2. So the second difference, this is what we call the first difference. This is what we call the second difference. You can see that the second difference is not changing. Therefore, we have a constant second difference. If you have a constant second difference, then you have a quadratic sequence. Now, very important. If you have a constant first difference, you have a linear sequence. If you have a constant ratio, then you have a geometric sequence. If you have a constant second difference, then you have a quadratic sequence. Understood? That's how we identify these sequences, by making use of those facts that I've just stated. Understood? Okay. So with quadratic sequence, the second difference is constant. We will learn how to find the general term in grade 12. But for now, I want you to remember the mechanics of a quadratic sequence. So this is what makes it quadratic. So let's say, for example, right, let's say they want us to find the seventh term. Then the way we'll do that is use what we know. What do we know? We know that the second difference is constant. So this will go up like that. This will be 2. 9 plus 2 is 11. 11 plus 25 is 36. Come down here again. 11 plus 2 is 13. 36 plus 13 is 49. So the seventh term will be 49. Right? That's how you would find a term in the sequence. Now let's say if they want you to find the general term, the 100th term. If you want you to find the 100th term, you'll most probably be given a question like this, of this nature. To find the general term, start with n squared, then add or subtract by the different natural numbers. For example, I'll start off with n squared. Tn is equal to n squared. If I put in 1 here, if I put in 1, Tn is equal to n squared. 1 squared is what? 1. But what do I have in the sequence? I have minus 1. So it'll be 1 or n squared minus 2. Why? Because when I put in 1, I get 1, but what do I have in the sequence? I have minus 1. So therefore I have to subtract 2 from 1 to get minus 1. So whatever term you put in here, you just have to subtract 2 and you'll get the terms of the sequence. See if I put in 2. Watch here. If I put in 2. 2 squared is what? 4. 4 minus 2 is what? 2. 3 squared is what? 9. 9 minus 2 is what? 7. 4 squared is what? 16. 16 minus 2 is what? 14. So that's what we're doing. We're starting off with the very basic quadratic sequence, n squared, and then we're either adding or subtracting some constant to get the new sequence. Understood? It cannot get more difficult. It cannot be more difficult than that, right? Because if it was more difficult than that, then we will start going into grade 12 topics, right? But at a grade 9 level, you will most probably be given the quadratic sequence where you're just starting off with the basic one and you're adding or subtracting by some constant. Understood? So when you're given if they want you to find, let's say, terms for small values of n, you know what to do. Complete this diagram and get the term value. But if they want you to find the general term, then you need to use Tn is equal to n squared and add or subtract by some constant to see if it can give you the terms of the sequence. Right? It can never get more difficult than that. Right? Because if it does, then it's more grade 12 work. Okay, and let's look at the cubic sequence. The cubic sequence, to find the general term, you use n cubed, then add or subtract by the different natural numbers, exactly as we did above. So let's look at the first one. You have 1, 8, 27, 64, 125, right? If you put 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Now let's say you're given this sequence. If I'm given this sequence, now look at the sequence, I'll say, okay, I have 6, 13, 32, 69, and 130. Find the first differences. 13 minus 6 is 7. 32 minus 13 is 19. The fact that we don't have a constant first difference, that means we are not dealing with a linear sequence. So take that out. Then we'll say, okay, let's look at the next one. 13 over 6 is equal to what? 2,166 recurring. Then we'll say 32 over 13 is what? 2,4. 2,45. The fact that these are not the same, that means we don't have a constant ratio, which implies that we're not dealing with a geometric sequence. Right. Then let's look at the next one. What's the next sequence we've dealt with? Quadratic sequences. Take the differences here. This was 7. This was 19. This is 37. And then if you take the differences between these two terms, 19 minus 7 is 12. 37 minus 19 is 18. The fact that the second differences are not constant means we're not dealing with a quadratic sequence. So therefore, we are dealing with a cubic sequence. Can you see how I walked you through all of it? We started off with linear, then we went to geometric, then we went to quadratic, and then we come to cubic. Right? Now, if you're dealing with a cubic sequence, and they want you to find the general term, then you need to use the n cubed. Okay, so we start off with n cubed. If I put in 1 here, what do I get? I get out 1. But what do I have in the sequence? I have 6. So 1 plus what number will give you 6? Plus 5. And therefore, if you try this for all the numbers, let's put in 2. 2 cubed is 8. 8 plus 5 is 13. 3 cubed is 27. 27 plus 5 is 32. And so on. So therefore, this is the general term for this cubic sequence. Understood? So now you can find any term given the position of the term. So they give you the 6th one. If they want the 7th one. If they want the 100th term, you can find it. Understood? So that's what you're doing. You're starting off with linear. Right. If you're starting off with linear, you need to check for a first constant difference. No first constant difference, it's not linear. Then we will look for geometric. Right? If we look for geometric. If we have a geometric sequence, then you have to have a constant ratio. If there's no constant ratio, then you have to move to the next one. What's the next one? Quadratic. Right? If you want to have a quadratic sequence, then you need to have a second constant difference. And lastly, if it's not if you don't have a second constant difference, then you are most probably dealing with a cubic. And if you're dealing with a cubic, start off with the basic cubic sequence and add or subtract by some constant. If it's anything other than that, then you're dealing with a problem that's not great. You're dealing with a problem that is not supposed to be in the grade 9 syllabus. So it has to be one of this 4. Understood? So please take this down. Follow these steps whenever you're given any grade 9 number patterns question. You should. This will be the diagram that you must remember when you walk into the paper, because it will enable you to solve any question. Understood?